Example 6 says find the geometric mean of 18 and 54. So with the geometric mean of 18 and 54, we're going to use, the form a over x is equal to x over b. A and b being my extremes, x being my means. I plug in my 18 and my 54. So I'm going to say a squared is equal to this 18 and 54, 18 times 54. So I can just multiply those two together, or I can go, you know what, I need to start taking out square roots. And that's what I'm going to do, because I take the square root of both sides. So I get the square root of 18 and the square root of 54. So I want to look for perfect squares in these. So I know that 18 is 9 times 2, and 9 is a perfect square. Sometimes what I'll do is I'll just write at the top a list of my perfect squares. So let's do that real quick. It can be helpful. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is, I guess I should put little squares here. 5 squared is 25, 6 squared is, I'm going to put in 30. 6 squared is 36. And we're going to leave it, just go that far out for right now. But so I got 9 times 2 is 18. So I have a is equal to the square root of 9 times 2 times 54 is divisible by 9 as well. That would be 9 times 6. And 6 doesn't have any perfect squares in there. So I'm just going to go ahead and I can say a is equal to the square root of 9 is 3. And then I have my other square root of 9, so that's another 3. Then I have the square root of 2 times 6, which is 12. And when I look at that, I got to go, okay, any perfect squares in 12? And the answer is yes, 4. So I'm going to say a is equal to, well, 3 times 3 is 9, the square root of 4 times 2. So then a is equal to 9 times, the square root of 4 is 2, the square root of 2. So then a is equal to 18 square root of 2. So the geometric mean between 18 and 54 is 18 square root of 2, except I made a measurement blunder here. 4 times 2 is 8, but 4 times 3 is 12. So this is 18 square root of 3 as my answer.